inferno fueled by crude oil is a nightmare scenario for any ship. But what steps can you take to extinguish this dangerous fire and ensure the safety of your vessel? This video will reveal the essential techniques and procedures to combat this threat. And the most important, that every year countless ships face the threat of crude oil fires. This devastating hazard can quickly spread and cause catastrophic damage. This video will empower you with the knowledge and skills to effectively extinguishing such fires and safeguard your ship and your crew. Imagine a vessel which is engulfed in fires with thick black smoke billowing into the sky. This is a terrifying reality of crude oil fire. Learn how to overcome this perilous situation and secure the well-being of the crew and the vessel with this comprehensive guide. So I have developed this specific video in order to safeguard. But how you can do that? Have you ever seen how a crude oil is burning? Let's see how I made this test. First of all, what I did, I used a small quantity of crude oil. It's just a small quantity, and try to light it up. So you can see that the crude oil, it's not lighting up because the volume, it's really small. It does not have any gases, and also we do not have inner gas in our atmosphere here. It is 21% oxygen. So I tried once more. The only thing that you can see, we have change in the viscosity of the crude. So basically, as I heat it up, the viscosity is changed. So it became really easy to flow. So let's see a little bit further. Okay, let's move it here. I try just to light it up from the bottom to see if with the transfer of the heat on the bottom it will generate enough vapors, and then these vapors will be ignited. So now I have a much bigger volume, much higher volume of the crude, and basically fill the cap of the bottom cap of a aluminum can. As you can see, by closely bringing the flame, it changed also the texture of the crude on top of it. So basically, yes, that specific point absorbs the heat, and this is the way how you see this texture change on the crude oil surface. So you can see then it disappears. Just look how it's changed locally here when we bring the fire closely. And in order to start crude oil burning, you can see it's actual crude oil. It needs to heat up and then release the light ends in order to sustain the fire. Without any vapor creation, the product does not ignite itself. So this is, yes, the fire of crude oil. This is actually how it burns. And also you can see that I have blown with my mouth on the fire itself, and the fire goes to extinguish. So this is also a really great method to extinguish fires, with a sudden and rapid blow to the source of the fire. So what it makes, it supply a lot of oxygen directly, more than it's required to sustain the fire, and the fire goes off. It is also a really great way to extinguish fires without having extinguishing media. Basically, it is a huge volume of air which is directly supplied to the crude oil itself, and then with the dilution of the air with the high speed, high volume, high concentration of the air, we dissolve the vapors. So basically we remove that part of the vapors that sustain the fire, and the fire gets off. And you can see that in order to fire up again, we need to bring a source, a ignition source, in order to reignite it. So by itself, also the product, yes, the temperature of the product, it's not on the ignition point, of the self-ignition point. That's why you're able still to extinguishing. And also what happens through the time that the crude is burning, it burns also high volume of light ends. So basically, if it has started and, let's say, fired for some point, which can be, let's say, some minutes or hours, it will burn all the light ends on it. So what will remain, it is only the thick crude, what remains there. And then also this crude has a higher ignition point. So basically the light ends ignites much quicker, much faster. And that's why it's really important to not overheat the crude while we're transferring. So we need to know exactly, by tasting, by physical tasting of the crude, how we are able to do this heating. It's really important to not change its structure, to not lose the light ends, because with the loss of the light ends, we lose also a high volume of products. It can be, let's say, 300 cubes, 400 cubes, depend of the crude type. And I really like, yes, how the drops are falling, how you can see some of the bubbles has been created, and these bubbles basically they are slip on the top texture of the crude, showing the surface tension of the crude. So basically the surface of the crude are able to sustain the drops. It's really a great view to see this behavior and this sliding of these small bubbles on top of it. I just test, yes, the texture of the crude to see, yes, how it moves. But you can see now the light ends has been disappeared mostly. Okay, still we have them here. And now I will show another way how to extinguish. Let me show you. It is by closing on top of it, and basically we eliminate. So what happened, the fire is burning all the oxygen inside in this container, and then the oxygen disappears and the fire goes off. So this basically shows that if we remove one of the source of the triangle or of the square, which is the chemical reaction, we are able to eliminate the fire. So basically the triangle, it is the fire, the media, the source, yes, heat, fuel and oxygen. If we remove the oxygen, the fire goes off. If we remove the fuel, the fire goes off. If we remove the heat, the fire goes off by cooling down also. So in order to prevent fires and also to fight the fires, you have to do real testing. And also the best thing is to do the real tests with the actual product that you have. So basically you take that crude, you make the simulations, you run the tests, you run whatever it is, let's say, available, and then you have the much accurate MSDS available. Okay, let's see how the fire goes off. And even I had some small opening, but this opening didn't help at all. So the oxygen also flowed here, and you can see, yes, how the circulation goes here This is called the natural circulation. So you can see that the air inside the cold and hot air start to circulate, and it's also a really great example to see this circulation in reality. We can also simulate how the flow goes up and down with this difference of the temperature. And this is also similar, yes, what happens in the clouds. The hot air goes down and the cold air goes down and the hot air goes up. And also here we are visualizing it, so you can see that we have this kind of flow here. And this is also this kind of flow that we would like to achieve when we are doing the heating of crude oil or any other product. It can be, let's say, biofuel, it can be any kind, it can be bunker, it can be any product we imagine that requires heating or maybe not requires heating. First we have to test, first we have to run all the simulations, and then we're able in much a better way, a greater way, to transfer our product safely and reliable, that it will end it to the refinery, and we will take as much as possible great products with great quality without changing the structure, the texture, the quality, and the quantity as well, which is also really important. Thank you very much. Don't forget to subscribe to the channel, and also don't forget to read the description below, join on the links, and join one of our membership, which is really great opportunity to learn, skill up, level up, not only technical but also in the professional level and the professional development. Thank you very much, and see you in the next video. From MOC Inside and Mihail, bye bye.